Hello everybody. In today's video I'm gonna show you how to factorize any polynomial you want. And today I'm gonna explain the topic which is called Horner's scheme or Horner's method that helps you to factorize any polynomial, binomial, monomial, and so on. So let's begin. Assume that we have any function f from x. And Horner's scheme helps us to factorize this function in this way. So x minus any number a, I will explain what a is, x minus a times new function g from x plus f from a. Okay, so what is a? A is one of the divisors of a number that becomes last in our function. So for instance, this polynomial x squared minus 5x plus 6, so a here may equal 6. So now let's get the divisors. Okay, 6. So minus 1, 1, minus 2, 2, minus 3, 3, and of course minus 6 and 6. So any of these numbers can be the roots of the equation x squared minus 5x plus 6 equals 0. So, but honestly, we're not interested in solving the simplest equation. So don't you like solving just the simplest ones? Me neither. So oh yes, I'm sorry. This value, this number f from a is just the rest after the division of f from x by x minus a. Okay. So if the polynomial f from x can be divided by x minus a, that means that the value of the function in the point a should equal 0. Okay? So, and here's how Horner's scheme actually works. Consider that we have a polynomial 2x to the power 4 minus 3x cubed plus x squared minus 2x plus 3. Okay? So, and here let's draw a table. This Horner scheme. Under the letter A, let's write all the divisors of the last number of the coefficient. Okay? Minus 1, 1, minus 3, and 3. That's it. And horizontally, from left to right, we should write all the coefficients that stand before x's. Okay? So they are 2 minus 3, 1 minus 2, and 3. So indeed, we have 2x to the fourth minus 3x cubed plus 1x squared minus 2x and plus 3. So how do we work with this table? So let me explain it this way. So, in the first column, we just rewrite the number that we have on the top of the column. Okay, so just copy to all of the rows the value of this column. So just 2. And look, every following column should be calculated in this way. We multiply the divisor with the previous coefficient that we get, and then it should be added with this value of this column that we have now. Okay, so minus 1 times 2 is minus 2, minus 2 minus 3 minus 5. 1 times 2, 2, minus 3, minus 1. Minus 3 times 2, minus 6, minus 3, minus 9. 3 times 2, 6, minus 3, 3. And so on. Minus 1 times minus 5, just the divisor multiplied by the value of previous column, and then added by the value of column that we have now. 5 plus 1, 6, minus 1 plus 1, 0, 27 plus 1, 28, 9 plus 1, 10. And let me continue to the end. So here minus 2. Oh my gosh. Here we have minus 86. Here we have 28. And look, if we can just factorize this polynomial without any rest, that means that in this column we should get a 0 from a particular divisor. So let's try our best so that we could calculate the rest after division of a polynomial f from x by the binomial x minus a, okay? So minus 1 times minus 8 is 8. 8 plus 3, 11. So minus 1 is not the root of the equation f from x equals 0. And neither does 1. 1 times minus 2 plus 3, 1. Minus 3 times minus 86, we will definitely not get 0. So just I'll set cross here, okay? 3 times 28 is 86 plus 3, 89. So none of these divisors are the roots. And it was actually expected. And you should not be afraid of this situation. You have 4 variants how to factorize this polynomial, but with using the rest after division. So the simplest one is this choice, the second row. Okay, let's factorize. So x minus a, here we have x minus 1 multiplied by 2x cubed, because we divide the polynomial by binomial x minus a. That means that the power decreases by 1. So 4 minus 1 is 3. Here, minus just x squared. 3 minus 1 is 2. Here we have 0, so we write nothing here. And we have minus 2. Plus 0x minus 2. Okay, parentheses are closed, and we have 1. We write it after all of the parentheses. So this polynomial is factorized with a huge success. Okay. So let's factorize an easier one now. 2x squared minus 5x plus 3. Let's factorize it. So we write just letter A. Under the letter A, we write all the divisors of 3. So minus 1, 1, minus 3, 3, okay? And now we create columns. From left to right, we should write all of the coefficients of the polynomial. So 2, minus 5, and 3. Now let's factorize it. In the first column, we just copy the value of the first column, okay? And now we do the same. We just multiply the divisor by the value in the previous column, and then we add this value to the column that we have now, to the current column, yes. Minus 2 minus 5 minus 7, 2 minus 5 minus 3, minus 6 minus 5 minus 11, 6 minus 5, 1. Okay, and we do the last thing. Here we should get at least 1 0. So if in a particular row we get 0, then the divisor, which is in this row, is the root of the equation. 2x squared minus 5x plus 3 equals 0. Okay? Minus 1 times minus 7. 7 plus 3. No, we do not have a root here. 1 minus 3 minus 3 plus 3, 0. Great. So a equals 1. So we can just do this way. X minus 1 is 1. Because 1 is allowed here. Since the rest after division, the polynomial by binomial x minus a is 0. So that we can divide it without any doubles. We get an integer. Okay, x minus 1 times 2x. Since we divided the polynomial by the binomial x, our biggest power is decreased by 1, and every power of x is decreased by 1. 2x just minus 3. Great job. We succeeded. Here we'll receive 36. No. 3 plus 3, 6. No. So 1 is the only one, A, that is allowed to use here. So, and here the rest, f from 1, equals 0. Indeed, if we substitute x equals 1, here we do receive 2 minus 5 plus 3. It's 0. If we have an equation f from x equals 0. Okay, just let's solve this equation. So we have the multiplication of two binomials. At least one of them should be 0. So just let's make each factor equal 0. Then we have x is 1 and x is 3 over 2. These are our roots of the equation f from x equals 0. So isn't that easy after the explanation? Well, that's it, guys. If you like this video, please hit the like button and don't forget to subscribe my channel and watch my previous videos. So thank you for your attention. See you next time.